Hello everyone, welcome to Schrödinger's cat, and this is Devabrata, and today we will discuss the important topic, the harmonic oscillator or parabolic potential, and this is a topic of quantum mechanics. So in quantum mechanics, IIT JAM, there are coming the 9 number of questions, and JEST 8 to 9 number of questions, and NET 8 questions, and GATE 8 to 9 questions. Total classical mechanics, and for harmonic oscillator at least 1 or 2 questions in each exam. So basically we will discuss here first one, the analytic method, and the wave functions, algebraic and operator method, or basically here 3 part: energy eigenvalues, energy eigenstates and matrix representation and expectation values, and third one are the isotropic, harmonic oscillator and the degeneracy part. So our first topic, analytical method, that we just here first of all we consider the, and one more thing is that I just first write some formula and concept, and after that we should solve the previous year question of JAM, JEST, NET, GATE and TIFR, and if we get more time after that we just discuss the basic theories in this topic, and that lecture is basically for the exam point of view. So f minus kx is basically m d2x dt2, and our final equation for that harmonic oscillator would become minus h cos square by 2sm d2 psi dx2 plus half m omega square x square psi equal to e psi. So basically this is our differential equation, and we just solved for the parabolic potential, and after power series solution we will get the compact form, that d2 psi b xi square is equal to xi square minus k psi, where xi is equal to root over m omega by h cross into x, and k should be 2e by h cross omega, and its general solution would become psi of xi is equal to hn xi minus e to the power minus xi square by 2, where hn is the Hermite polynomial, and the standard differential equation would become d2hn by dxi square minus 2xi dhn dxi plus 2n 2n hn is equal to 0. This is our Hermite polynomial equation. And basically here that h0 value 1, h1 equal to 2 xi, and h2 equal to 4 xi square minus 2. This is our first approach, and after that wave functions, for drawing wave functions we just plot here that the ground state and the other states would become and we just do here, this is our psi nx and this is our x, this is origin. So basically first one would become this one is n0, n1, n2, n3, and first one would become this Gaussian distribution. Second one, that this type of. Third one for n equal to 2, and last one for n equal to 4. This is our wave function here, like that, and we just deduce where the play in the graph, how to draw this graph actually. So after that we move forward for our algebraic method or operator method, and in this topic we just write some formulas. That the basically first one for operator method, we have two operator. First one is a 1 by root 2 x cap plus I px cap. This is basically the lowering operator or annihilation operator, and a dagger is 1 by root 2 x minus ipx. This is basically raising or creation operator, and another one is n is number operator. So apart from this we have x root over h cross by m omega x cap, px m omega h cross px, and h Hamiltonian h cross omega h cap, and h basically half px square plus x square, and another one the Hamiltonian h number operator plus half, basically h n plus half h cross omega. So we have here some result that h acting on n is basically n plus half ket n h cross omega. So this is basically n plus half h cross omega ket n, and some other important formulas, that the commutation relation of a and a dagger is basically 1, number operator and a is basically minus a. n and a dagger is basically a dagger. n norm, this is 1, and n number operator n, this is basically n. And when a acting on n, we should get a acting on n, we should get root n ket n minus n. One step is down here, and a dagger acting on n, root n plus 1, rise one state ket n plus 1. And there are some algebra about this, that like we have eigenvalues here. Eigenvalues is basically en n plus half h cross omega, where n equal to 0, 1, 2, 3 dot dot. And an eigenstates or eigenvector for harmonic oscillator is basically sin xi is equal to m omega by pi h cross to the power 1 by 4, 1 by root over 2 to the power n factorial Hermite polynomial hn xi e to the power minus xi square by 2. This is our energy eigenfunction, and we have deduced some state here, that ket n is basically root over 1 by n factorial a dagger to the power n ket 0. Generalization form, that a dagger to the power n by root n factorial ket 0. And here some other results, that position x root over h cross by 2m omega a plus a dagger, and the another one px 1 by I root over m omega h cross by 2 a minus a dagger, and del x fluctuation is basically root over x square expectation minus x expectations whole square. And we have another algebra of number operator, that n is basically n positive plus n negative, where n positive be a dagger positive a positive, and n negative be the a dagger negative a negative, where a positive be the plus type and a negative be the minus type. And this commutation a plus minus a dagger positive negative should be 0, and n positive negative should be j plus minus m. And one important result, that state of n positive n negative would become a dagger to the power n, a dagger positive to the power n, a dagger negative to the power n minus n negative, here n positive, by root n positive factorial, just generalization with positive and negative sign, n minus factorial, state 2 system, so 0 0. And our one more topic is basically the matrix representation and expectation form. So basically in this matrix representation we have some state vector that we have some state vector representing with this matrix form is basically the A diagonal element should be 0 and upper diagonal element should be root over 1, root over 2, root over 3 like this, and its Hermitian conjugate A dagger should be 0, 0, 0, 0 this diagonal element, and lower diagonal element basically root 1, root 2, root 3 dot dot dot, and some expectation value for that m omega square by 2 n x cap square n 1 by 2m n p square expectation is basically 1 by 2 n Hamiltonian expectation, half of Hamiltonian expectation, and this result is known as the virial theorem, and this virial theorem would also come in our classical mechanics central force problem. So our another topic, isotropic harmonic oscillator. So basically for isotropic harmonic oscillator, so we have deduced for two-dimensional harmonic oscillator where potential V xy would become V xy is basically half m omega square x square plus half m omega square y square. This is our, so energy nx plus half h cross omega plus ny plus half h cross omega, and this is basically for 2D, and we write here nx plus ny plus 1 h cross omega. So nx plus ny is basically n plus 1 h cross omega, and for 2D harmonic oscillator the degeneracy is Gn for 2D basically n plus 1, and for 3D same case would have happened, that the basically we have nx plus ny plus nz is nothing but n. So E nx ny nz is basically nx plus ny plus nz plus half 3 times 3 by 2 h cross omega, and this is basically n plus 3 by 2 h cross omega, and so basically the degeneracy for 3D it would become half n plus 1 into n plus 2. This is basically for the 2D n plus 1. This result is very important for entrance exam purpose for solving many tricky problem. 2D harmonic oscillator degeneracy n plus 1, and for 3D it would half n plus 1 into n plus 2. So basically we have covered these topics in generalization of some concept and problems for entrance, and we go through some problem here, and after we have time, this is basically for entrance purpose, we just cover in your theoretical class briefly. So basically our first problem number 1 is basically the IIT JAM 2017. Consider a one-dimensional harmonic oscillator of angular frequency omega. If 5 identical particles occupy the energy level of this oscillator at 0 temperature, which of the following statement about the ground state energy 0 is or are true? This is basically for MSQ type questions. So first of all, we just try to solve this. First of all, that for the electrons and protons, for that we get E naught. Basically this is quantum state and the particle made like in this form. So E naught would become 2, total number of particle 5. So distributed in this way, 2, 2, 1. So 2 half H cross omega, 3 by 2 H cross omega, 5 by 2 H cross omega, plus 2 into 3 by 2 H cross omega plus 5 by 2 H cross omega, one rest particle. So it would become 13 by 2 H cross omega. And for fermion, it's basically one particle in one state, and E naught would become H cross omega by 2, 3 by 2 H cross omega, 5 by 2 H cross omega, 7 by 2 H cross omega, 9 by 2 H cross omega, and the result would 25 by 2 H cross omega. And for bosons, basically all particle is in the state here. So E naught is basically 5 particle into half H cross omega. This is basically n plus half H cross omega, and for n equal to 0 ground state, E naught half H cross omega, basically called the 0 point energy, and it would become 5 by 2 H cross omega. So answer 13 by 2 A, C and D would correct. And one more thing, in a MSQ type question, if there are no partial marking, so be careful to solve this type of questions. Question number 2 is basically from the TIFR exam, TIFR GS 2016. A one-dimensional harmonic oscillator of mass m and natural frequency omega is in the quantum state psi 1 by root 3, ket 0 I by root 3, ket 1 I by root 3, root ket 2 at time t equal to 0, where ket n denote the eigenstate with eigenvalue n plus half H cross omega. It follows expectation value x of the position operator each. So we have to find basically the expectation value of the position operator, and we just solve here. Just first of all, the time evolution of an expectation value, we have the formula that ddt of some observable A is 1 by IH cross commutation of AH plus differentiation dA dt expectation. And for position operator, that ddt of x IH cross expectation x h plus its constant time derivative should be 0. So you should find x h is basically x h Hamiltonian p square by 2m plus half k x square. So basically x square p square by 2m, this is operator, so 1 by 2m constant outside here, 2IH cross p, and result would become IH cross p by 2m. And we should find here the expectation value of x. This is our questions. We just find xh. This is our equation number 1, and after we just calculate the time derivative of x equal to p by m from this result. This is our equation number 1. Simultaneously we just calculate for momentum. You should do in your homework that ddt of p, it would become m omega square x. Homework, you just find this result, and after on from equation number 1 and 2 we just write here that d square dt square expectation of x equal to 1 by m ddt of p, and put this value 1 by m minus m omega square expectation of x, and after that d square dt square x plus omega square x expectation is basically 0, and this is basically the harmonic oscillator equation, and its solution would become a, basically the operator cos omega t plus b sin omega t. Now we just put at the boundary value. We just put here the boundary value, and basically at t equal to 0, the boundary condition x would become at t0 x0 expectation, and here we get the constant x0. So after you just find the momentum operator expectation is basically ddt of m d expectation x ddt of. So basically the we just derivative here m a omega outside sin omega t plus m b omega outside cos omega t, just derivative, and at t equal to 0 we just put here boundary condition for momentum operator. Same, we just get p0 and b constant value, it would become p0 expectation by m omega. Here only x0, but here m omega. So our x would be, just put in this equation number earlier, x0 expectation, sorry, x0 cos omega t plus p0 expectation. This is bracket, this is expectation value p0 by m omega sin omega t. This is our main result, but we just put here this value. This expectation of x and expectation of p at t equal to 0. So for find this result, we just consider here, let us find p 0 expectation. So we have the formula, basically the m h cross omega I root 2 a minus a dagger. So p expectation would become, just this is our in bra form, 1 by root 3 I by root 3, just state is in the bra form, 1 I by root 3 2, and this value m h cross omega by I root 2 a minus a dagger, and here this is the cat form, because we just find expectation, basically this one is this form and another is bra form and another is cat form. Basically the Dirac notation used here, 1 by root 3 0 I by root 3 1 plus I by root 3 2, and this is our main. And after we just calculate here that root over m h cross omega by I3 root 2 0, sorry, this will be in the bra form, I bra 1 minus I bra 2, and this value would become a minus a dagger, and this result would be cat 0 I cat 1 plus I cat 2, and it would become, just multiply here, and a acting on n and a dagger acting on n, we would get the result. This you just act and find the value match with this result here, I 3 root 2 I plus root 2 plus I minus root 2, and after one we just get this value, just I plus root 2, which is basically the root 2 by 3 root over m h cross omega. So you just calculate, this is our expectation of p, and you just calculate the expectation of this, basically the x, we just equation x h cross by m omega a plus a dagger by root 2 is basically h cross by 2m omega a plus a dagger, and you just find x expectation. do this in your homework, and I just write here the result. You just match with this result. Here this value would become 2 by 3 root over h cross by m omega. This is basically in TIFR question, 5 marks, so lengthy question, so you should calculate very carefully, and we just match here 2 by 3 h cross m omega by m omega, and it would become that expectation of p should be put here after we get expectation of p root 2 by m omega. So this is basically p expectation by m omega is equal to 1 by root 2 expectation of x. So final conclusion, after putting the expectation of x and p in t equal to 0, we just get x expectation is basically x0 expectation is common here, and put this value cos omega t plus 1 by root 2 sin omega t. This is our final answer of this TIFR lengthy question, 5 marks. Our next problem is in question number 3, JEST 2019. So basically, they consider a system of 15 non-interacting spin polarized electrons. They are trapped in a two-dimensional isotropic harmonic oscillator. Potential is given such that h cross omega is 1. Choose this unit, and what is the ground state energy of this system in this unit. So total system ground state energy, we just do this theory in our problem and formula class, just two-dimensional. So basically here would the degeneracy, two-dimensional, basically the degeneracy of 2D is basically n plus 1th. So non-interacting spin polarized electron means direction of spin is fixed. Basically here spin non-interacting and spin polarized, direction is fixed. So the energy of the system ESYS, first one particle energy h cross omega, two particle energy 2 h cross omega. Basically here n equal to 0, 1, 2 dot dot dot. When 0 h cross omega, 2 h cross omega plus 3 into n equal to 2, 3 h cross omega plus 4, n equal to 3, 4 h cross omega plus 5, n equal to 4, 5 h cross omega. Basically the GI equal to n plus 1 h cross omega. This is we should done earlier, and after we calculate we get 55 h cross omega. So basically 55 our answer, because h cross omega is 1 by the question. This is a numerical question from JEST. Next discuss question number 4 in CSIR net December 2018. The ground state energy of an anisotropic harmonic oscillator described by the potential, this one, half m omega square x square 2m omega square y square plus 8m omega square z square, is the unit of h cross omega equal to what? So basically we have this potential, we just write in the form of half m omega square x square plus half m 2 omega square y square half m 4 omega square z square. This is basically omega x, omega y 2 omega, omega z 4 omega. Basically the energy of the system E cis, basically nx plus half h cross omega x, ny plus half h cross omega y, nz plus half h cross omega z. Ground state, so basically nx, ny, nz would 0 and it would become half h cross omega, half h cross 2 omega, half h cross 4 omega, and after that 7 by 2 h cross omega. 7 by 2 h cross omega, this would be the answer. Question number 5, last question. So here we just discuss the all questions one type of JAM, JEST, NET, GATE and TIFR, 5 types of questions, and after solving these questions you just can do all the questions according to this concept, because we should choose here the questions from many different types. So the harmonic oscillator, just 1 minute for the changing my pen. So basically here the question is that the Hamiltonian for a quantum harmonic oscillator of mass m in the dimension h p square by 2m plus half m omega square r square, where omega is in angular frequency. The expectation value of r square in the first excited state of the oscillator in the units of h cross by m omega would what? So basically we have the r square expectation value is basically x square expectation plus y square expectation plus z square expectation, and so we just do earlier for the expectation value of the harmonic oscillator in the form of position and momentum. This formula we just write h cross 2m omega 2 nx plus 1 plus 2 ny plus 1 plus 2 nz plus 1. So first excited state, basically the nx 1, ny 0 and nz 0, and another possible should would become 1 0 0 0 1 0 0 0 1. This is basically triply degenerate. Triply degenerate. Basically we put this value and got the result 0 0 1 2 3 1 2 3 0. Basically we have 5 by 2 h cross by m omega, and our result, this is basically GATE NET type questions, numerical should be answer. So basically is in the unit of h cross omega, so this is the unit, so our value would become 5 by 2, is basically 2.5 would be our answer. So here we stopped our question discussions, and usually I just give the home tasks for the better understandings. So basically this is your homework, you just do in your home and mail me in the given ID. Just pause this video and take a screenshot here. Question number 1. Suppose a linear harmonic oscillator of frequency omega mass m is in the state this and t equal to 0. Two states psi 0 at psi 1. One is ground and first excited. You should calculate the expectation value of position. Second one, you used to calculate the probability of this quantum harmonic oscillator general state. Basically we just write here the formula that psi n is basically the a dagger by root n factorial ket 0 to n state, and another one you should measure the probability of this question. You just take screenshot and go ahead. Our next 1 2 3 and second homework is that you also take this screenshot, let 0 and 1 be the state of the ground first excited on the 1D harmonic oscillator, one dimensional harmonic oscillator, and the uncertainty del p is in the state this. So basically here quantum state is given 1 by root 2 ket 0 plus ket 1, and you should find the uncertainty in momentum del p. And another one, this is basically the 1D one dimensional harmonic oscillator. Here also given a quantum wave state ket psi, and you just expectation value of displacement. So here the expectation value of displacement x in the state psi would be minimum. So here this is a condition, minimum or maximum condition, you just put here the minimum and maximum conditions, that time derivatives functions of fx should be 0, and after you should find the value of b1 and b2. So basically you just problems in expectation value, probability and others. So these 5 questions you just do in your home tasks and mail me. Solve this homework, and if anyone needs this file of my YouTube lectures, just mail in this given ID catschrodingers1935@gmail.com. Thank you. Stay happy. And finally, goodbye to all of you. Have a great day.